5. This week we don't have as many problems to work on as normal, which is a great thing, I think, for most of you. So today we're going to be working on the first problem, finding the next terms of the arithmetic sequence of whole numbers. So what we see here, we have numbers 2, 8, and 14. And the easiest way to do this is just say we have 2, 8, and 6. And if we add 2 plus 6, it gives us 8. So we know that there's a plus 6. And then if we add 8 plus 6, it gives us 14. So in order to find the additional 2 sets of numbers, we will just add the last number, which is 14, plus 6. And so we'll say 14 plus 6 equals 20. To find the next arithmetic sequence, we will simply add 6 plus 20, and that will give us 26. Okay, let's move on to the next problem. Okay, this problem requires us to find the geometric sequence. So here we'll be simply multiplying. So we have 4 and 20. So if you know your multiplication, you know that 4 times 5 equals 20. So we know that we're going to be multiplying everything times 5 pretty much. So 4 times 5 equals 20. And then 20 times 5 equals 100. So in order to find the next two geometric sequences, we will multiply 5 times 100, which will give us 500. And then the next round we'll multiply 500 times 5, and that will give us 2500. So the answer is 4, 20, 100, 500, and 2500. Let's move to the next problem. Okay, the next problem requires us to interpret a tree diagram. These can be a little tricky because there's so many different ways that things can go. So let's get started. A class is choosing a president, a vice president, and a treasurer. There are 2 students running for president, Linda and Maria. There are 2 students running for vice president, Bob and John. There are 3 students running for treasurer, Amanda, Jessica, and Deborah. The tree diagram below shows the possible outcomes. Use the diagram to answer the questions. So question A asks, how many outcomes are there? So we'll start with laying out who all is running for what. So as you can see here, they have the president here, Linda and Maria, the vice president, Bob and John. Then we have the treasurer, Amanda, Jessica, and Deborah. So now you see these are all the people that are actually running for different positions. So now we can look at the diagram, and so we have Linda could possibly have for vice president Bob and John, and then the treasurer could be Amanda, Jessica, and Deborah for Bob. Or if it's John, it could be Amanda, Jessica, and Deborah. So these are all the possible outcomes if Linda was president. Now, if Maria becomes president, then Bob could be the vice president, or John can be the vice president. And then once again, you have Amanda, Jessica, and Deborah as one of their treasurers. Okay, so then here you can see the possible outcomes on the end. So you may have you may have Linda as the president, Bob as the vice president, and the treasurer as Amanda. So she could also have, let's say Linda, Bob, and Amanda as an outcome. So really she could have all 3 of these as an outcome. She could have Linda, Bob, and Jessica as an outcome, or Linda, Bob, and Deborah as an outcome. Okay, so you can see that each one of these names are pulled into the outcome in each incident. So then we have the president is Linda, the vice president is John. Then once again, we have the names listed. And the easiest way to do it is the way that they have it here up top, and just list the names in order as Amanda, Jessica, and Deborah. And they did it in all instances here. And then so if John is the president, you could have Amanda, Jessica or Deborah as the treasurer, and those possible outcomes could end up being Linda, John, and Amanda, Linda, John, and Jessica, Linda, John, and Deborah. So now you kind of see the flow of how the three possible outcomes could be. Well, once you get down here, count them all up or add them all up, you will see that it should be 12. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 possible outcomes that you could have with between the president, vice president, treasurer, and treasurer. Okay, so the next question says, how many outcomes do not have Jessica being chosen? So here, though, that's the answer for the last one. They added those all up. Okay, so here, which one does not have Jessica? Jessica for being the treasurer. Okay, so here we can just go through here. So we'll automatically take Jessica off this one because, we see her name and we're looking for all of the options that do not include her. So we'll check her off here, again here with here again, and there. So then we just add up these possible outcomes, and that should leave us with 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now that solves the second part of the question. Now let's go to the third part. Okay, the third question asks, how many outcomes have both Maria and John being chosen? Okay, since John is a vice president, he would not be on the list of treasurers. So you would automatically go here to look to find John, because John is running for vice president. So we'll definitely automatically look here on that side. And so here we see here that we have John for vice president, and it wants us to see both that have Maria and John on the same team. So here we see as 3 incidents: Maria and John and Amanda, Maria, John, and Jessica, Maria, John, and Deborah. So that leaves us with 3 outcomes. Okay, that's it for that problem. Let's move to the next one. Okay, counting principles. So this is the first one of these kind of problems, and it's very simple. So just watch it, and then you're like, oh, I didn't realize it was going to be that easy. Okay, Sam is studying the growth of a particular type of plant. He is testing the effects of 4 growth factors: lighting, age, temperature, and humidity. Here are the levels he's testing for. So lighting, age, temperature, and humidity, as they stated. And we have for lighting, low, medium, high, very high. Age, 1 month, 2 months, 3 months, 4 months, 5 months, 6 months. And for temperature, we have 20 degrees Celsius, 22 degrees Celsius, 24 degrees Celsius, and 26 degrees Celsius. And for humidity, we have low, medium, and high. He wants to find the number of ways of combining one level from each of the growth factors. How many ways are there? There are 4 factors to be tested. Once again, they're lighting, age, temperature, and humidity. For each factor, we were provided with the number of levels. So for instance, for lighting, there were 4 different levels. There were low, medium, high, and very high. And with each growth factor, they also gave us the different levels. So the only thing we will do in this problem is just simply multiply the number of levels within each growth factor. So we'll multiply 4 times 6 times 4 times 3, and that will give us 288. So there are 288 ways of combining one level from each of the growth factors. Okay, let's move to the next problem. Okay, for this problem, we have to do a factorial expression. This problem can look a little scary when you first look at it, but it's really not that difficult. Okay, so we have to evaluate 4 and 8 and 2 and 7. And so what we will do here is simply, the only thing you would do is, I'm just going to scroll down here to the bottom so you can see. So you would put 4 over 2 and put that in parentheses, and then times 8 over 7 in parentheses. So the only thing you do is you're going to start from the number 4 and go and count backwards till you get to 1. I'm sorry, I couldn't get my words out. And you count backwards until you get to 1. And then you do the same for 2. You'll count backwards until you get to 1. So you have 4, 3, 2, 1. And then for 2, you have 2 and 1. And the reason you have the 2 and the 1 in red, because those numbers are going to cancel out because they're the same at the top and at the bottom. So that leaves you with 4 and 3. So, you just simply multiply 4 times 3, and that will give you 12. Okay, now here on the other side, you have 8 and 7. So for the 8, you would just count down till you get to 1, and you will say 8, 7, 6, 5, 4, 3, 2, 1. And for 7, you would do 7, 6, 5, 4, 3, 2, 1. And all of the numbers that you see here that are in blue, all those numbers cancel out because they are the same on the top and the bottom, and that leaves you with 8. So you just simply multiply 12 times 8, and that will give you 96, and that's the answer. Okay, let's move to the next problem. Okay, for this problem, we are calculating permutations and combinations. So we have to evaluate P43 and 10C7. So don't get all like scared when you see this, because it's just like the last problem we just worked out. So here we're just going to stroll down here. I'm just going to show you how I would approach the problem. As you can see here, we have 4 and 3, and then we have 10 and 7. So you will always put the larger number up top. So 4 is up top, and then you have 4 minus 3, and then you will just work it out as we did before. And so you will count down till you get to 1. So, once you bring over your 4 and your 1 after working this part of the problem out. So you would say 4, 3, 2, 1, and then you'll bring over your 1, and then you'll cancel out the 1 since you have a 1 on the top and a 1 on the bottom. And so here, the next thing you would do is just multiply 4 times 3 times 2, and that will give you 24. Okay, so let's go ahead and work out 10C7. And once again, you put the larger number up top, and then at the bottom you will subtract 10 minus 7, which will give you 3. So you will count down. When you get to 10, you would say 10, 9, 8, 7. You will go all the way down to 1. And then again for 3, you will have 3, 2, 1. And so you will simply multiply 10 times 9 times 8, and that will give you 120. So that is your answer. Let's move to the next problem. Okay, word problems involving permutations. So the question is, Tony has been given a list of 6 bands and asked to place a vote. His vote must have the names of his favorite and second favorite bands from the list. How many different votes are possible? Well, we know that he has to at least pick 1, right? And so if he picks 1 band, that's going to leave him with 5 other bands to choose from as his second choice. However, you don't know which one he's going to choose, but if you simply multiply 6 times 5, you know that he has 30 possible votes. And if you click here, you can see all of the different options that he could have gone with. A, B, A, C, A, D, A, E. He could have gone down the list and deciding which 2 were his favorite. Okay, let's move to the next problem. Okay, this problem requires you to really pay attention to what the question is asking. So we're doing permutations, combinations, and the multiplication principle for counting. Okay, here it says serial numbers have a product. Serial numbers for a product are to be made using 2 letters followed by 2 numbers. So keep that in mind. The serial numbers for a product are to be made using 2 letters followed by 2 numbers. The letters are to be taken from the first 5 letters of the alphabet, with no repeats. The digits are taken from the 10 digits with no repeats. How many serial numbers can be generated? Okay, so let's scroll down here to the description. And that was why I was saying make sure you're paying attention, because it says remember we read that here, if you look here, the permutation of 2 letters are chosen from the first 5 letters. So we have 5P2. Okay, so 2 are the first 2 letters and of the serial number, and 5 are the 5 possible choices of the alphabet that could have been chosen. And so you see they have 5 over 3 equals 20. Now remember that they're doing this the same way as we worked out the other problems before. So they actually would have written out 5, 4, 3, 2, 1, 3, 2, 1 for the bottom, and then they would have canceled out the 3, 2, and the 1, which would have left them with 5 and 4, which gives them an answer of 20. Now at the bottom we have 2 digits is chosen from the first 10 digits. So we have P10-2. We put the larger number up top. So we have 10 over 8. And once again, they did it the same exact way. They went 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And for 8, they did the same. They just went to 1 from 8, like 8, 7, 6, 5, 4, 3, 2, 1. So they crossed out everything on the bottom row, and then it left us on the top row with 10 and 9. So 10 and 9, or 10 times 9 equals 90. So then you would multiply 90 and 20 together to find all the possible serial number options that you will have, and that will leave you with 1800. So that's it for this week. Bye-bye.